Okay, students, so today we'll be studying perimeter and area of plane figures. This is our first lecture and the only lecture for the month of April. So let's begin. So let's just ponder over what the meaning of plane figure is and what is area and what is perimeter. So let's begin. So plane figures are flat two-dimensional shapes. That means they are 2D shapes. 2D shapes mean that they can be only viewed from the front and from the back. A plane figure can be made of straight lines, curved lines, or both straight and curved lines. Okay, moving on. The word perimeter means a path that surrounds an area. In mathematics, the perimeter refers to the total length of sides or edges of a polygon. Polygon can be a figure with 3 or more corners. Okay. Area is defined as the space occupied by that object. So you can see in the diagrams what area and what perimeter means. Moving on. Okay, we come to the conversion of units. We all know that 1 meter is equal to 100 centimeter, but when it comes to conversion, let's see what happens. You square them. You square 1 meter square and you square 100 centimeter and you square that too. When you square 100 centimeter, it turns to 10,000 centimeters square. And when you have to convert 9 meters square into centimeters, you just multiply by the square of the centimeters with 9, which gives you 90,000 centimeters square. That means in 9 meters square, there are 90,000 centimeters square. Okay, if you have to convert from centimeters from a smaller unit to a bigger unit, what you do is you you just do the same, but 1 centimeter is equal to 1 divided by 100 meters. You can clearly see we cross multiplied there. So after dividing 1 by 100, it gives you 0.01. But when we have to find the square in terms of square, so you square both of them. When you square 0.01, you get 0.001. When you have to find centimeter, you have to convert 587 into meters, just multiply and you get the final answer. Moving on. Okay, here's a summary of perimeter and area of plane figures. That means I'll just tell you what the figures look like and what are the formulas. So I've written the direct value of pi in my formulas. So just to let you guys know that this figure, this shape is what represents pi. Moving on. Okay, the first shape is square. Okay, square looks like this. You can find its perimeter by adding all the four sides. And since all the four sides are same, you can just multiply one side by 4 to find the perimeter. You can find the area by multiplying two lengths. That is one length and L into L. That gives you L square. In rectangle, you can find the perimeter by adding the length and the breadth. Breadth can also be written as width. You add them both and you multiply it by 2, or you can just add all the four sides all together, and you find the area of the rectangle by multiplying the length and the breadth. Okay, for the triangle, you add all the sides for the perimeter, and for area you multiply half by breadth, which is b in the diagram, and height by a, which is a in the diagram, to find the area. Moving on. Circle. So you can clearly see what a circle looks like. To find its perimeter, you have to find its circumference. To find the circumference, you already know the formula. 2 pi r. I have written the direct value of pi here. So 2 into 3.142 into r. R is the radius. And to find its area, you just have to multiply pi by the diameter. Okay, in semicircle, to find the perimeter, there are two formulas, as you can see. They're both easy. You can grasp any one. And to find its area, you have to multiply half by the value of pi and by r squared. Okay, interesting shape. Parallelogram. Yeah, you can find its area, sorry, its parameter as the same in the same way as the rectangle, and you can find its area by multiplying the base, which you can clearly see in the diagram, and multiply by height. Moving on, the last but not least, trapezium. You can find its parameter by adding all the four sides, and you can find its area by multiplying half into A and B, which are the two parallel sides of the trapezium, and multiplied by the height. Moving on. Okay, what examples? Here are some examples to get you guys up to pace. Okay, so find the cost of fencing of a rectangular field 65-meter long and 55-meter wide at Indian 10 rupees per meter. So what you will do is you have the length, you have the breadth, you have to find the cost of fencing of a rectangular field. So you'll just add all the sides to get a length of the total field. And you, if a meter costs 10, you'll add both of the length and the breadth and multiply by 2 to get the parameter. When you get the parameter, you multiply by 10. Why? Because parameter is the total area, and if 1 meter has 10, then how many will 240 have? You just multiply and get the answer. Okay. Okay, moving on. Okay, the parameter of a rectangular field is 70 meters and its length is 15 meter long and its breadth. The field is surrounded by a concrete path. You can see in the diagram as shown in the figure. Find the area of path. Okay, what you'll do is let the length of field be x plus 15. As you can clearly see in the statement, its length is 15 meter longer than its breadth. So we keep the breadth as x, both are unknown. We only know the parameter. You put both the unknown values in the formula of the parameter of a rectangle. You can clearly see. You add the unknown x's, then you separate x. You clearly know we studied in algebraic expression how to separate a variable. You make it a subject, you get answer as 10 meters. I'll give you a minute to see how have I processed this. Okay, once you find x, you'll put it in as breadth. X is equal to breadth is x, so 10 is the breadth, and x plus 15 is the length. So you'll add 10 to 15 to get the length. For area, you'll do is you'll calculate the area of a hole. So you can see that the concrete part, including the field, is 5 meter long in its breadth and 2.5 meter long in its length. So you'll add just 2.5 on both of the sides and 5 on the both sides as well. You multiply them to get the area of the hole. Just simply multiply the length and the breadth of the rectangular field. When you minus that, you'll get the area of the concrete path. Moving on. Okay, there are 4 quadrants in this picture. Quadrants are the same way we deal with the semicircle, but let's catch the case. In this figure, 4 quadrants, you can see each of radius 2 cm are removed from a rectangle. So you have to find its area of the remaining shape. You just calculate the area of the rectangle. You can clearly add the breadths. 2 plus 3 plus 2 gives you 7, and you already know the length, which is 9. You'll multiply them and minus it with 4. You have 4 quadrants, right? You will write 4, and to find the area of one quadrant, you have 1 upon 4 into pi. I written the direct value into the radius, which is 4. If you minus them both, you'll get the area. Moving on. Okay, trapezium. This is particularly easy because you have 4 sides. As the figure PQRS shows a trapezium where PQ is equal to 15 centimeters and PS is equal to 8 centimeters. If the area and the perimeter trapezium are given in the question, calculate the length of RS and QR. You can clearly see where RS and QR lie. So for RS, we have to calculate, we are given the area, right? So we'll just use the formula of area to calculate the unknown value. You can clearly see I put everything in the formula. PS is our height. So we have put everything in the formula. RS is unknown. We'll make it the subject. We'll move RS to one side and move everything to the other side. If one thing is multiplying on one side, you'll divide on the other. If one thing is adding on one side, you will subtract on the other, and vice versa. Okay, for QR, we know all the lengths except for QR, so we also know the parameter. We have to find the unknown value to separate QR from the rest of the values. When you are adding on one side, you subtract on the other side, you get the final answer. Please practice this and it will help you more. Okay, that is about it for my lecture. I hope you guys understood. See you guys soon. Take care and practice hard. Thank you.